Hello, Math Studies students, and welcome to your online lesson. Today we're going to be talking about surface area, and I'm going to break this video up into two parts, one for next class and one for the following. But our overall learning intention is that we'll identify and find the surface area of prisms, pyramids, cylinders, spheres, and cones. And to start off with, in this lesson, we'll be focusing mostly on prisms and pyramids. We'll know we are successful when we can efficiently solve problems involving the surface area of prisms, pyramids, cylinders, spheres, and cones. So, what is a prism? A prism, which is also known as a cuboid, and I'll go on to say that, in fact, IB on their tests and problems almost exclusively, if not exclusively, refer to prisms as cuboids. Now, don't confuse a cuboid with a cube. A cube is a specific type of prism that's made entirely out of square faces. But a cuboid is just another name for a prism. And what is a prism? It's a three-dimensional object with two identical parallel surfaces known as the bases. And all other surfaces, also known as faces or lateral faces, are rectangles or other parallelograms. But for our class, they will be rectangles. For IB tests, they will be rectangles. So again, what do we have? We have a base pictured here at the top and the bottom of the figure, but they don't have to be. But there's two identical shapes. Here they're hexagons. They could be squares. They could be just regular old rectangles, triangles, any shape that you can imagine. But you'll have two of them that are identical, and those are our bases. And then connecting those, at least in this class, all of our lateral faces are all going to be rectangles, similar to the one that I'm tracing out right here. In this case, there are 6 of those rectangles, and they're identical because we have a regular hexagon for our bases. But they don't have to be identical, and we'll look at that in an upcoming example. So we're talking about surface area today. What is surface area? Surface area essentially is the sum of all of the two-dimensional surfaces that create a 3D object. So in the case of a prism, that would be the sum of the area of both bases and all lateral faces. I've got an image here that's essentially a box, and I would probably think of the base as being this part right here, not at the bottom. And we would have one, of course, on the other side, technically, right there. And those would be our bases. They are identical. Here, since we're dealing with a rectangle, there's going to be, interchangeable bases if you want. One way or another, we're dealing with 6 surfaces. And if we unfold this box, you end up with this, where you have the top, back, bottom, front, and we can see all of those outlined here. Remember, the bases will always be the same. The other rectangles do not have to be. But again, we're just finding the area of each of these surfaces, similar to if we were to make a box or if we were to wrap a box with wrapping paper. How much wrapping paper would we need? That's really the question that surface area answers. Or another question that could be asked is, how much paint would I need to cover this entire object, including the top, the bottom, and all of its sides? That's what surface area really is dealing with. So when it comes to finding the surface area of a prism, we're just dealing with regular old polygons and mostly rectangles, in fact. And we can use our area formulas that we already know for polygons and rectangles and then add all those up. So let's try it out. In this first example, we're given a triangular prism or cuboid, and we're asked to find its surface area. Well, the first thing we'd want to do is kind of find out where the bases are. And here's another example where the bases are definitely not at the bottom and top. Our bases, remember, have to be identical. And the only spot where I really, for sure, immediately see identical objects that are parallel to each other would be this triangle that we have out here at front. And then we have an identical one happening back here. So there's 2 of them. That's one way you can identify that those are the bases. And so as I find the area of this entire prism, I'm going to start with the bases. And again, I know there's 2 of them. But 2 of what? Well, they're triangles. So we would have 1/2 base times height is our area formula for a triangle. However, 2 and 1/2 cancel each other out. They are reciprocals. Or you just think of what is half of 2. It's 1. Or if I think of having 2 halves, again, that's 1. So we're going to take our base and our height, multiply them together. Well, the base of this triangle and again, I'm just focusing on the 2D triangle right now, is 4 meters, and the height of it is 1.5 meters. Clearly the picture is not drawn to scale, so I'm going to take 4 times the 1.5. And you might say, oh, Mr. Peacock, you need to make sure that you are doing 1/2 for all of these. However, we have 2 triangles, so we already got rid of the 1/2. And we get a final answer here of 6. Since this is area, we could put the label on as meters squared, though I'm hesitant to put any label on because we're not really done yet. We still have to deal with the lateral faces, which are all rectangles. Now, if I look at the rectangle that's sort of on the right here, I'm going to trace it in green. This rectangle would have a formula, again, of base times height, and our base would be 6, and our height would be 2.5. So as I multiply those together, I end up with 15. However, we're going to notice on the left side, we have the exact same rectangle because these double tallies here that I see on both sides here indicate they're the same. So that left side of this sort of tent-like object would have the exact same one. So I really could have just multiplied this by 2. In fact, maybe I'll do that. So we'll multiply by 2 because there were 2 of these rectangles. And so I'm going to end up with 30 now for those. And then there's still like this floor of the tent, if you will. And so the floor is right here. And that has a base of 4 and a height of 6, or vice versa. 4 times 6, which gives me 24. Now, as I add all these together, and again, they're all area, meters squared, we end up with 60 meters squared. And that is the surface area of our prism or cuboid. So on to pyramids. What is a pyramid? Well, we've seen pyramids in the real world, lots of buildings or even statues, and certainly the famous ancient Egypt pyramids have this sort of similar appearance. And a pyramid is a 3-dimensional object with a polygon base and triangles for all of its faces. So what are the differences between a cuboid or prism and a pyramid? Well, again, a cuboid or prism has 2 bases. A pyramid only has 1. In this class, that shape that is the base will usually be a regular shape, and what I mean by that is like a square or an octagon that you might see for a stop sign. All of its sides and angles are congruent within the figure. Here we do have an example of a square, much like the famous Egyptian pyramids. And then the faces, rather than being rectangles on a pyramid, are all going to be triangles. And we're still going to use our basic knowledge of how to find the area of those individual parts, whether they be squares, rectangles, triangles, or otherwise, to find the surface area of our pyramid. So, for our last example here today, we are going to find the surface area of this pyramid. There's 3 measurements that are given here, and we have, again, a regular base, which is a square, a regular quadrilateral, meaning that all of its sides are equal, all of its angles are equal. And then I have 2 measurements listed here for the height and the slant height of this pyramid. Now, the height would be this 15 inches, and that's how tall the pyramid is if I start right in the center of the pyramid and measure it straight up. That might be very useful for something like volume, but in our case, we're not dealing with volume, and we're finding the area of each one of its faces, which is that surface. And the 17 that we have over here is called a slant height, but it is actually the height of the side or the face of this pyramid, which is a triangle. So we'd have a base right here of this triangle, and then we'd have a height right here of this triangle, and that 17 represents the height of the triangle. Why do I care about the height of the triangle? Because I'm finding surface area, and for every triangle, the formula is 1/2 base times height. Again, this 15 we have here is the height of the pyramid, not the triangle. So what am I going to use? Well, 16 is this length that we have out front, but since it's a square on the bottom, it should be 16 on all of its sides. So our base is 16. Our height is 17 for that triangle, and we're going to multiply that by 1/2. However, how many of these do we have? Well, since there are 4 sides on that square base, there are also 4 faces or 4 triangles that we have. So we can take all of this and multiply by 4. And I'm just going to go ahead and throw that into the calculator. And I end up with 544 square units, in this case inches, for the surface area of all those triangles or lateral faces. Now we need to find the area of our base. And it's just a square, so base times height, since it's a type of parallelogram or rectangle, or an even shorter way to do that is just 16 squared. 16 times 16, which gives me 256. Now, if we compare the area of the base and the area of those triangles, you'll notice that the combined area of all those triangles is much more than the base. And it always will be. If you ever, are doing one of these problems and maybe you forgot to multiply by the number of triangles that you had, that would be a good way to indicate that we made that mistake, because you have to have more area on all the faces than you do on the base. Otherwise, the faces would essentially fall down on top of the base. There has to be more of it. And then when we add all this together, we end up with 800 square inches in total. And that, ladies and gentlemen, is surface area of a pyramid. Now you'll notice for both the prism/cuboid and the prism, or and the pyramid, I wasn't using any special formula. I was just taking, formulas that we already know for triangles, rectangles, things of that nature, and then combining them together to get this total surface area. On our next video lesson, we'll be looking at the sphere and the cylinder and the cone, and we'll be using some special formulas for that. Till next time.